Good morning, children. Today we will discuss about infinitesimal contact or canonical transformations. Infinitesimal contact or canonical transformations. Let us go with the presentation. Okay, let us see infinitesimal contact transformations. So infinitesimal, very small change. So the transformations in which the new set of coordinates. So we have capital QK, capital PK already. These are the new set of coordinates. These differ from the old set of coordinates. Small qk, small pk by a very infinitesimal, that is qk is equals to qk plus delta qk. That means here delta qk it is very small change. That means the new set of coordinates differ from the old set of coordinates by very small change. That means capital qk is equals to small qk plus delta qk, and capital pk which is equals to small pk plus delta pk. So these are called infinitesimal contact transformations. Okay, so it has been showed earlier in the solid examples that generating function f2 is equals to sigma k qk comma capital pk generates the identity transformation, that is capital qk equals to small qk, capital pk equals to small pk. That means here already we have solved the examples that generating function. So we have a generating function f2 which is equals to sigma k small qk into capital pk. So these generating function it generates the identity transformations. That means here capital qk equals to small qk. So same identity transformations, and capital pk is equals to small pk. So the generating function giving an infinitesimal change in the variables can be readily written as, that means these generating functions giving very infinitesimal change, very small change in the variables. So we can write as f2 is equals to f2, here it is generating function f2 is equals to sigma k small qk capital qk plus, that means here we are attaining here a small change, that means here plus epsilon g qk comma pk capital pk. So here epsilon it is an infinitesimal parameter of the transformation, and g of qk comma capital Pk is arbitrary. So by substituting 55 in equation number 27, so what we have equation number 27, Pk is equals to dou f2 by dou qk. Already this is equation number 27. We have this one, and here qk is equals to dou f2 by dou pk, and h dash equals to h. We have this one equation number 27. So by substituting this one f2, this one in equation number 27. So 27 pk is equals to dou f2 by dou pk. That means pk. Plus. So let us see here. So here pk plus epsilon dou g by dou qk comma qk is equals to dou f2 by dou pk. That means here we are doing the differentiation here. So dou f2 by dou pk means we are doing differentiation sigma dou by dou qk of g. So here also same way. So capital qk which is equals to dou f2 by dou pk, here qk plus epsilon differentiation dou by dou pk of g. H dash is equals to h, equation number 56. So therefore capital qk minus small qk is equals to delta qk, which is equals to, already we have capital qk is equals to qk plus delta qk, capital pk equals to pk plus delta pk. Already these are infinitesimal contact transformations. So here if you consider, so by bringing this qk to the left hand side, qk minus qk which is equals to delta qk, which is equals to uh, here qk is equals to, we have this one. So qk minus qk which is equals to delta qk which is equals to epsilon dou g by dou pk, and pk minus pk capital pk minus pk which is equals to delta pk. So here we are bringing a small pk this side, that's the here capital pk minus small pk which is equals to delta pk minus epsilon dou g by dou qk. This is equation number 57. So here the difference capital Pk minus small pk, this one it is very small change, very small. Capital Pk minus small pk, the change is difference is very small. That means it is infinitesimal. So we can replace capital Pk by small pk in the derivative, and also g of qk comma p by g of qk comma capital small pk. That means we are replacing capital P here but with small pk. So equation number 57. So we can replace here capital Pk by small pk. So delta qk is equals to epsilon dou g by dou pk. So dou g by here just we are replacing capital P by small p. So delta qk equals to epsilon dou g by dou pk and delta pk which is equals to minus epsilon dou g by dou qk. So equation number 58. So in the case of infinitesimal contact transformations, description is transferred to the function g instead of the original generating function capital F. So thus G is the new generative function which generates the infinitesimal contact transformation. So let us consider a special case in which epsilon is equals to dt and g equals to capital H. Just we are replacing epsilon with dt and with h in equation number 58. So here with dt and g with h. So we can rewrite the equation and Hamilton's equations of the motion. Delta qk equals to epsilon means here dt. In the place of g, we are replacing with h, dou h by dou pk, and which is equals to, so we can write this one dt into dou h by dou pk is nothing but q dot k. Again, q dot k is nothing but dqk by dt. So here dt get cancelled, we will obtain dqk. And delta pk equals to minus dt dou h by dou qk. So dou h by dou qk again p dot k. P dot k is nothing but here again dpk by dt. Dt get cancelled. We will obtain here dpk. So this is equation number 59. So these changes in the conjugate variables represent an infinitesimal change in a coordinates in the time dt. That means we can observe a very small change in equation number 59. So which gives us transformation from the variables small qk, small pk at a time t to qk plus dqk and pk plus dpk at time t plus dt. So hence the motion of the system in a small time dt can be described by an infinitesimal canonical transformation generated by the Hamiltonian h of the system. So evidently the motion of the system in a finite interval of time is described by a succession of infinitesimal canonical transformations generated by the same Hamiltonian. So in other words, motion of a system corresponds to the continuous evolution of canonical transformation. So thus we can say that Hamiltonian of the system is the generator of the motion of the system in the phase space with time. Thank you, children.